Okay, so let's jump in and talk about, is it a function or is it not a function? Safe to say, this is part of paper 1. Inverse functions are not a big part of paper 1. So when it comes to questions on inverse functions, you're looking at about sort of 5 to 8 marks in your final paper, but functions are a massive part of paper 1. So you will definitely have a question on a parabola, you will definitely have a question on a hyperbola, and you will either have a question on some kind of inverse function. So either the inverse of the parabola or the inverse of the exponential function, et cetera, et cetera. So in total, functions does end up being a huge part of paper 1. So let's just start in the very beginning and just talk about what we mean when we say, what is a function? So without me telling you, what do you guys understand by the word function? What does it mean to you if to say, is something a function? What does this word specifically mean to us? And you can pop it into the chat. What do you understand a function to be? Okay, so Ria Betsway, you're on the right track. There should be one input and 2 outputs. All right, that makes it a specific kind of relation. Hlorby, you're also right. A function cuts a graph at one point. It depends what that point is. If it's a horizontal point, then it's okay. But if it's a vertical point, then that may not be okay. Masejo says an X value with a corresponding Y value. Absolutely. That's lovely, Lorato. So we use a rule. A function is a rule. It's a function relationship to determine output values when we use input values. Absolutely. So it is a relationship. It is a relationship between inputs and output. So it's a relationship between what we would typically call our X values, which are our inputs, and our Y values, which we would refer to as our outputs. But judging on what it is that you were saying, there's a little bit more to the story than just that. Okay, Kimaya, you are saying, Kimaya, you're saying, if a vertical line is drawn, it must cut the graph only once. So you're talking about the vertical line test. Absolutely. So when we talk about a function, all right, specifically here, a function is a rule. It's a mathematical rule by means of which each element of the domain is associated with only one element of the range. Right, and we're going to talk a little bit more about what they mean by the word elements and domain and range as well. So when they specifically talk about the word domain, what does the word domain mean for us? Domain is our set of what sort of values? That's it, our X values. Good, Oratile. Nice. Well done, everybody. Okay, all possible X values. Quite right. What's our range? That is our set of Y values. Okay, so this means our Y values. Okay, that's it, quite right. But in order for it to be a function, 2 or more elements of the domain may be associated with the same element of the range as well, but it will be a relation and not a function if one element of the domain is associated with more than one element of the range. All right, and a good way for us to understand what they mean by elements and relations and then being associated with one another is to look at it in a picture format. Okay, so yes, absolutely, don't forget to take screenshots. So if we have a look at the first example over here, all right, if we look at our domain, which is our first circle over here, we've got -2, 4, 5, and 3. So all of those elements are different. And they're each associated with a different element in the range, all right? So we would refer to this as a function, but we would say specifically that it is a one-to-one function because each x value is associated with only one y. So this is a one-to-one function. All right, can you give me some examples of some one-to-one functions that you know? So what one-to-one functions are you? No problem, Ayanda. We've only literally just started. Some examples of one-to-one functions. What do you know is a one-to-one function? Quite right. So y equals 3x plus 2 is a straight line. So the linear function, not a parabola. Ola, not a parabola. A parabola is not a one-to-one function. So a linear function, yes, absolutely. What else, guys? What else is a one-to-one function? Where one element of the domain is associated with one element of the range. That's it. Good. Exponential function. Good. Well done. The exponential function. Okay, if you guys have done the section at school, then the inverse of the exponential function called the logarithmic function would also be a one-to-one. And there's one more that you guys know. Yep, the log function. Good, Pagelo, the log function. There's one more. That's it. Okay, iPhone, I don't know who you are, but hyperbola is correct. Okay, the hyperbola is also a one-to-one function. Now let's go and have a look at a many-to-one function. So that's what this one is. Okay, so if we have a look here, we have got these elements in our domain, and we can see here that two different elements of the domain are associated with the same element of the range. Okay, so when 0 goes in, 4 comes out. When 1 goes in, 4 comes out, all right? This is said to be a many-to-one function, all right? It is okay for the x values 0 and 1 to be associated with the same element of the range, in other words, 4, okay? Each x value still only associates with one y. So that's why this is a function. It is a many-to-one function. And some examples of many-to-one functions. There's one that you've studied in grade 11 and you know very well. And then there is another one that you're going to study this year as well. Any idea what that is? Let's have a look at what you guys are saying. Okay, so the parabola. Yes, absolutely. The parabola is a many-to-one function. Now, I want to ask a question because I've seen it here in the chat. Is the inverse of the parabola, Zepo, is the inverse of the parabola still a function? Is the inverse of the parabola still a function? Correct. Correct. No, it's not. Okay, so the inverse of the parabola is not a function. The parabola is a function, but the inverse of the parabola is not a function. We've got to do something to the original function in order to make it a function. All right, there is another graph that is also a many-to-one function. What is that called? Does anybody know? We haven't done it yet, but you will be doing it this year. Yeah, many-to-one. Okay, so Lemogang, the inverse is not a many-to-one function, but the parabola is a many-to-one function, yes. Not the log graph. It's actually called, let's just see if somebody says it before I said, not the gradient function, the lady. No, the logarithmic function is a one-to-one function. It's actually called the cubic function. the cubic function. All right, and you're going to be studying that in a lot of detail when it comes to doing calculus this year. They're going to be your teachers, and I'll do it with you guys as well. We'll teach you how to draw them, how to find the equation, what they mean, what you're plotting, the x-intercepts, y-intercepts, all that kind of stuff. So we'll be talking about that in a lot of detail. My enemy. Okay, all right. So a many-to-one function is still a relation, is still a function, because we have two x values associated with the same y. So because each x is still only associated with one y, that makes it a function. Now, if we have a look at the situation over here, all right, we have the opposite of what we've just looked at. Okay, so -2 is associated with 16, but here we have 4 being associated with 1 and with 6. Okay, so because 4 is associated, that element of our domain is associated with more than one element of the range. That means that a situation like this is not a function. Okay, so we would say that this is not a function, and we would refer to it as a one-to-many relation. Okay, so these are not specifically functions. All right, and if it's not a function, then it means that you cannot use functional notation. So you cannot refer to it as f of x. Okay, you're not allowed to do that because it's not a function. This sort of notation is strictly for functions only. Okay, so we can only write f of x if we're talking about functions. Okay, all right, now let's talk a little bit about the horizontal and vertical line tests. I don't know if you want to take a screenshot there, but I'm going to explain to you what this means. It's just a bit of information. The vertical line test, let's just highlight what's important here. The vertical line test is used to see whether a graph is a function or not. All right, so if the ruler only ever cuts the graph in one place, as the ruler moves from left to right across the graph, then that graph will be a function. Okay, if the graph fails the vertical line test, then it's not a function. Okay, so the vertical line test is there. Let's just put here, so the vertical line test tests is it's a function. But we've also got a horizontal line test. So the horizontal line test means we can use this to determine whether the graph is a one-to-one or many-to-one function. All right, so if the ruler only ever cuts the graph in one place as the ruler moves horizontally up or down across the graph is a one-to-one function. If the ruler cuts the graph in more than one place during the horizontal line test, then it is not a one-to-one function, it is a many-to-one function. So our horizontal line test okay, so here, is it a one-to-one function? Or is it a many-to-one function? So that is the purpose of our vertical and horizontal line tests. So now let's go and have a look. Okay. Let's draw a line here. Let me just put a vertical line on the page, and we can basically take this with us wherever we go. Okay, so just grab hold of it. If we have a look at question B, first of all, right? If I want to determine whether it's a function, I'm going to put my vertical line over here. I'm going to drag it left to right. Is this a function? Is the graph only being cut once when I'm using my vertical line? So in B, is it a function? Yes, quite right. Okay. Similarly, when I move that out the way, and I now grab my horizontal line, if I drag this over here, again, it only cuts once. What does that tell me? What is this horizontal line test telling me? That B is a what? Put it in the chat or unmute and speak. That's it. Okay, it is a one-to-one function. Good. All right, it is a one-to-one function, absolutely. Let's have a look at C quickly. What do you reckon about C? Is it a function?
No, it's not.
It's not a function. Why is it not a function? Where is it failing the test? What do you guys think? Is it a function?
Why it is.
Oh, remember, let's raise hand. So you can find a reaction and you just need to click on that reaction and raise your hand, and then teacher Lee will say, oh, Amina, and then you will just yes, there we go, Amina. That's the spirit. You can
Cool.
unmute.
Amina,
Okay, so
yeah, lovely. Amina, go for it. I agree, Yanela. Okay, so this is a function. Yes, it is a function. Quite right, absolutely. Because it's passing the vertical line test. Okay, so as far as E is concerned, it is a function. It passes the vertical line test. When it comes to the horizontal line test, however, let's drag it, move it over here. All right, it's cutting in two places. Okay, unlike this only cut in one place. But this over here cuts in two places. Right, so that means that it has to be a what sort of function?
One to many.
Many to one. Okay, so we use the words one to many when we're referring to a relation. When we're talking about a function, then it is a many to one. Okay, so it is a many to one function. All right, so let me just put that in there as well. So it is a function because it passed the vertical line test. It is a many to one function. All right, let's go down here and let's have a look at the circle. Is the circle a function?
No.
No.
No,
No, the
it's not.
circle. No, it's not. The circle is not a function. All right. No, Penga, that's not possible. No, because then it wouldn't be a function. All right, so no, that's not possible. Okay, so a circle is not a function. All right, so we wouldn't even bother looking at the horizontal line test. Okay, now the graph at G, what do we call this? What sort of graph is this? The graph at G.
It's the hyperbola.
It's a hyperbola. Absolutely. Is a hyperbola a function?
Yes.
Yes. Okay, it's passing the vertical line test. Is it a many to one function or is it a one-to-one function?
One to one.
It is a one-to-one function. Okay, let me just grab my vertical line. And again, my horizontal line. And if I pull it down over here, can you see it's only cutting in one place? Okay, so this is an example of a one-to-one function. So let's just put that there. To one function. All right, very nice. Now, what I would like us to, I see there's lots of messages in the chat here. Yes. Okay. Nozipo, you said, I don't understand, how does it cut in many places? Are you talking about the circle? Nozipo, which one are you talking about? Which letter?
The line, ma'am.
Which line?
The line that cuts the graph.
Okay,
The
so
vertical and horizontal line.
okay, so if you have a look, okay, your graph is the function that's been sketched, okay? So this over here, what I'm highlighting in yellow are your axes. That's your x-axis, and this is your y-axis, okay? Your function is this in green. There's your function, okay? So if you have a look at the pink line and the green line, the pink line only ever cuts the green line in one place. Okay, if you move it up or down. Over here, it's cutting it in two places because it's cutting it over here. Sorry. It's cutting it over there, and it's cutting it over there. So it's cutting it in two places. All right. If you look at your vertical line, again, it's only ever cutting it in one place. So if I move it from left to right, it's only cutting in one place. The pink line is only cutting the green line in one place at one particular moment in time. Over here, if we go up, right, it's cutting it again. It's cutting it in two places. All right, so it's cutting it here. Let's do this in blue. And then again, over there. Okay, that's why the circle is not a function, and it's why your hyperbola is a function. Yes, Chamo, you've got a question?
Yes, ma'am. May you please explain the vertical line test again?
Sure. So your vertical line test is there to determine whether your function is a function or not. So in other words, if we have a look, I'm going to show you another situation, okay? Let's have a look at this one over here, right? Let's draw a vertical line. Let's get a different color, and let's draw a vertical line. Oh, come on. There's a vertical line, okay? If you look at E and you compare E to F, right? Can you see the purple line is only cutting your black graph in one place only when you drag it from left to right? So it doesn't matter where I leave it, it only cuts it in one place, or one place, or one place, no matter how far over to the left or to the right I am. But if I bring my vertical line over here now, is it only cutting your graph in one place? It's not. It's cutting it in two places, absolutely. So on the left-hand side, E, that is a parabola, and it's a many-to-one function. F is not a function at all. Okay, so it is the inverse of C, and it's not a function. Okay, it's failing the vertical line test. Okay.
Yes.
If you have a look at the horizontal line test now, so let's do a horizontal line, okay? A horizontal line is only there to determine whether it's a many-to-one function or whether it is a one-to-one function. So we're not going to use the horizontal line test on F because F is not a function. So now if we go and have a look here, can you see that the horizontal line is cutting your parabola in two places? So that makes it a many-to-one function, a many-to-one function. But if I have a straight line, like, let's just get hold of this over here. If you compare it to this one, then it's only cutting in one place. So it doesn't matter how far up or how far down I go, my purple line is only cutting my graph in one place only. So that's what makes that a one-to-one function. Okay. Now, something that's also really important for us is not to just determine whether it's a function or not, and if it is a function, whether it's one-to-one or many-to-one. We also need to be able to write down our domain and range for each relation, because these are questions that we get asked in functions and we get asked in inverse functions. All right. So let's go through these together, and I'd like to hear from you guys as we do this. Right. So in question B, please put your hands up, and then we can take one person at a time. I want you to tell me whether it's a function or not. If it is a function, whether it's one-to-one, many-to-one, and then I want you to tell me what the domain and the range are for each particular graph. Okay, so as far as no, the horizontal line is not used to test whether the inverse is a function, because the only way that you can, so like, for example, when it comes to your parabola, okay, your parabola, the inverse is not going to be a function. So your horizontal line test is not even going to work, right? So no, the horizontal line test is there to test whether it is a one-to-one function or a many-to-one function. Okay, Lemogang, you've got your hand up. Do you want to do B for us? You're welcome to unmute and speak.
Yes, ma'am. Function. Question B is one-to-one function. The
Lovely.
domain for X. The domain for x is negative infinity and infinity.
All right,
Then
and
the
how would
range is
you,
negative infinity.
okay, quite right. So how would you write that? Would you use set builder notation, or are you going to use interval notation? What sort of notation do you want to use?
Circle.
Okay, so if you were going to write what the domain was, if I told you to write down the domain, what would you write?
The domain
Yes.
x
Mm-hmm.
x e open brackets negative infinity comma
What sort of,
infinity.
sure, what sort of brackets, round brackets or square brackets?
Ma'am,
With what sort of brackets, round brackets or square brackets?
round brackets.
Round brackets. Okay, so round brackets, because we cannot include infinity. All right, and it would be the same with your range. Okay, so from negative infinity to positive infinity, just like that. Okay, good job. Well done. All right. Okie dokes. Let's go and see who else has got a hand up here. And we're going to do the next one. Okay. Is it Dimple? I hope I said that correctly. Dimple, do you want to do C for us?
Yes, ma'am.
Go for it. Okay.
So C is a function.
Mm-hmm. What
It
sort of function?
is a many-to-one function.
Lovely.
And the domain for the function is going to be D is an element of brackets, round brackets, negative infinity to positive infinity.
100%. Lovely. Okay. And as far as your range is concerned?
My range is going to be Y is an element of block bracket 0 up to infinity.
Lovely. Okay, very nice. Okay, very good. Well done. Perfect. Okay, so now, why can't we include infinity, Nozipo? Because it doesn't end. Okay, so you cannot include something that has no end. All right, so that's why we have to use a round bracket, just as Yolanda was saying. Okay, Wasani, can I have the range and domain in interval notation? Absolutely. Okay, so in interval, this is interval notation over here, right? So we would refer to this as interval notation, what I'm highlighting in green here, that would be interval notation. All right, set builder notation. So this is also interval notation. Set builder notation looks like this. So I could do that with my Y value, for example. So set builder notation means that I would write my range as Y is greater than or equal to 0 in this case. All right, so this is interval notation with the brackets, and this is set builder notation with the inequality symbols. All right, just want to see what you guys are saying in the chats. Okay, so Mihlali, how do you determine R? Very good question. All right, so Mihlali, the implication with these arrows at the end over here is that the graph continues to get wider and wider and wider in both directions. So it keeps going off to the left-hand side towards negative infinity, and it keeps going off to the right-hand side to positive infinity. Okay. As far as your range is concerned, the graph has its turning point at 0, where y is equal to 0, because it's turning on the x-axis. So it's going to be every value of y that's either 0 or bigger than 0. Okay, so Mihlali, bearing that in mind, why don't you do D for us? Tell us whether it's a function or not a function. If it is a function, what type it is, and then the domain and the range. Try D, Mihlali. Maybe Mihlali is shy. Okay. Kedi, go for it. You've got your hand up. You're welcome.
Ma'am, the range is from -4, the block bracket is y is an element of -4 to positive infinity, and then the domain is from -infinity to positive infinity, round brackets.
Absolutely. Okay, so you could, yeah, you could write it like that if you wanted to. Okay.
And it is a many to one function.
It is a many to one function, quite right. Good stuff. Well done. Okay. Okay. Maite, where did you ask a question? So I see a star with a Y, but I don't see another question. Okay, how did you get your domain? All right, so I answered that question, right, because I explained that the graph would continue to go all the way to negative infinity and all the way to positive infinity, left and right. Okay, remember your domain is your set of x values. We spoke about that in the beginning. Okay, so all parabolas have got the same domain unless it has been restricted. So x is always going to be an element of the real numbers, okay, unless your domain has been specifically restricted, which is something that we're going to have a look at. Okay. Sihawu. Yes, it would be wrong. Okay, because the implication here, Sihawu, is that the graph is growing off to negative infinity and to positive infinity. It doesn't stop here. Okay. All right, Tsegofatso, can you please do D in set builder notation? Let's just have a look. Please do D in set builder. So we don't typically use the infinity symbol in set builder notation, right? So it's not usual for us to write y is greater than negative infinity, but smaller than infinity. But if you were going to write set builder notation, that's how you would do it. And similarly with x in this case. So y would be greater than negative infinity, but smaller than positive infinity. But this is not the usual way of setting it out. Okay, as far as the infinity symbol is concerned. Okay, all right. I hope I've answered everybody's questions. Let's have a look. Ma'am, what does the x value signify? When you say x value, what do you mean, Pinga?
Ma'am, sorry, I didn't raise my hand. I don't know how to with this app here. But I have a question of how exactly you would solve C, because I see that everyone who answered in terms of the y value was able to say, like, for example, D was y is an element of -4, but on C, like, there's no value on the y-axis and no value on the x-axis. So how would you answer that?
Okay, so that's fine. You're asking me a question that I've actually already answered for somebody else, but it's fine. I don't mind answering it again. The reason for this, okay, is because this graph over here has a minimum of -4. Okay, remember your minimum or your maximum are your y values. Okay, so they form part of your range. This graph over here, its minimum is at 0.
Right.
So it as far as y is concerned, okay, it does not get any smaller than 0. Okay, 0 is the smallest number that it possibly is. Right, so that's how I know that as far as my range is concerned, it has to be 0 or any number bigger than 0. That's what that means. If I then wanted to write that in interval notation, I could say y is an element from, I've got to put the smaller number on the left because 0 is included as an output. I would say 0, and then I go up to positive infinity, and then I write a round bracket like that. Okay.
For the x values, ma'am, what would you add?
Okay, so x is always going to be the same for every parabola. X is an element of the real numbers, okay, unless the domain has been restricted, which it hasn't been in this case, okay, because of the arrows at the end here. So they are implying that it just keeps going off to negative infinity and off to positive infinity. Okay.
Thank you, ma'am.
All right, no problem. All right, so now I'm going back. Pinga, let's just have a look. Okay, so the X is there to represent the domain. That's what the X represents. It is your domain. It's your set of X values. Okay, Pinga. It would have to be the other way around. Okay. Oh, no, sorry, I'm talking nonsense. Yes, not you can never say, you can say. For D, you can do exactly that. All right. So your option for D, all right, is to write this as Y is greater than or equal to -4. There's nothing wrong with that. Okay, so that's correct, Zehofatso. Cabello, yes, a parabola is always a many-to-one function. Correct. Pinga, the domain is left and right. Okay, so what is the graph doing in terms of X? Okay, because X goes from left to right. Okay, so it's essentially how wide it is. All right. Your range is what's happening vertically. Okay. Does that make sense to everybody? Okay. Okay. All right, no problem. All right, so yes, it's getting wider. All right, so that's why those arrows are there. The graph keeps getting wider and wider and wider infinitely. Okay. To the right, it's positive infinity. Okay, because if you look at your x-axis, Mihlali, numbers get bigger to the right. Other numbers get smaller to the left. Okay, so to the left is negative infinity, to the right is positive infinity. Okay, as far as y is concerned, positive infinity is up, negative infinity is down. Okay, so negative infinity is over here for x, positive infinity is here on the right. For y, positive infinity is at the top, and negative infinity is down there at the bottom. Okay. All right. So it's very important that we get all these sorts of things ironed out. Okay, Maite, you're asking, so when we are not given coordinates, we write infinities. No, because if you have a look in the case of D, all right, you are writing infinity because the graph continues going up forever and ever, right? As far as X is concerned, the graph keeps getting wider in both cases. It would be the same thing with E. The graph keeps getting wider in both cases, right? It's not a case of when you're not given a number that you write infinity, right? It depends where the turning point of the parabola is. So as far as your range is concerned, here your minimum was at 0. So that's why you used 0 here. Here your minimum was at -4. So that's why we used -4 over here. All right. As far as the graph at E is going to be concerned, all right, now we've got a graph that's a different shape. It doesn't have a minimum. It's now got a maximum. So if I wanted to write the range at E, now I would have to say Y is an element from negative, oops, sorry, wrong bracket. Negative infinity, and it goes up to the biggest number that it is -1. So I would do that. Okay, or if I wanted to write this with set builder notation, I would say Y is smaller than or equal to -1, like so. Okay, because each value is going to be smaller than -1 because -1 is the maximum. Over here, this 0 was a minimum. This -4 was a minimum. As far as my domain is concerned, it's still going to be X is an element of the real numbers. Okay, or the other way of saying that is X is an element from negative infinity to positive infinity. Okay, does that answer that question, Maite? Yes, Wasani, quite right. Quite right. Then the graph would have been shifted up to the top. Okay, so in other words, Wasani, what you are asking here is if you had a parabola that, oh, sorry, that's not the best diagram. So if you had a graph that did that, say Wasani, and that was 4 over there, then you would say that y is greater than or equal to 4. Or your alternative is y is an element from positive 4 is your minimum. Okay, so here we would say 4 up to positive infinity, like so. X would still be an element from negative infinity to positive infinity. All right, now someone's asked if they can do f, but the problem with f, Lemochang, f is not a function. Okay, all right, it's not a function, but we can talk about that now. I just want to answer these questions. So, ma'am, at B, if I said the domain is x, yes, absolutely. So saying that x is an element of the real numbers. Let me just put this on the side over here for you guys as well. If I say x is an element of the real numbers, it means exactly the same thing as saying that x is an element from negative infinity to positive infinity. This means exactly the same thing. Okay, so that would just be another way of you being able to write that. Okay. Cabero, the other graph that you're going to study this year that's going to be a many-to-one function is the cubic function. Okay, that looks like this, J. That's a cubic function. That's a many-to-one function as well. All right, and the reason why it is a many-to-one function is because if you have a look over here, let's just put some lines on the page. So there's a vertical line. Let's just get a horizontal line. Okay, so as far as our vertical line is concerned, it's passing the vertical line test. Okay, so that means it's a function, yes, because it passes the vertical line test. Horizontal line, if you have a look over here, it's not passing the horizontal line test. Okay, because it's cutting the graph in 3 places. All right. So if it was up here, it would be cutting it in 2 places, but it actually cuts it in 3 places. Okay, so that makes it a many-to-one function. Okay, that's the cubic function. All right. Yes, Michali, that's what the R represents. It represents the set of real numbers. Okay, right. Okay, Amina, what was your question?
Sorry, ma'am. I just want to know, how is J cut in 3 places?
Okay, so just have a look very carefully over here, all right, where it is right now. Okay, when I say it's cut in 3 places, the first place over here, Amina, is there. The second place is there, and there's the third cut. Can you see that? Okay, Amina?
Yes, ma'am, I understand. Thank you so much.
All right, lovely. Okay, so now one that would be useful for us to do is question G, especially given all the questions that we've had this evening. Okay, so yes, f of x is for functional notation. All right, so if you write f of x, then it's a function. All right, if you have to use another letter, if it's not a function, then you would write y equals. Okay, but y equals can be used for functions and for those that are not functions. F of x is only for functions. So if something is an inverse function, then we change the notation and we write it like that. So that's what we use for an inverse function. This is what we use for a function. Okay. Absolutely. So because y equals mx plus c is a linear function, we can define it in terms of y, and we can also define it in terms of f of x. But if you have a look at question F, I cannot use f of x notation to describe f, okay, because it's not a function. So if I wanted to write what this was, all right, so over here, the original function would have been y equals x squared. All right. Now, because I'm doing the inverse of that, I would say that it would be y equals, okay, and I'm switching my x and my y around. Okay, so x equals y squared. All right, so now if I want to so yeah, but I'm not allowed to use f. All right, so over here, if I now want to write y as the subject of the formula, I cannot say f of x, right? I would have to say y equals plus minus the square root of x, like so, but I'm not allowed to write that as f of x because it's not a function. Okay, in order to answer your question. Sorry, I'm writing all over the place here. Wasani, yes. Okay, so when you talk about a function that is an inverse, what they mean they've done is they have reflected the graph over the line y equals x. That's what an inverse is. It's a reflection over the line y equals x. When we're talking about a log function, we have taken an exponential graph and we have reflected it over the line y equals x. Or if you want to look at it, that we switched x and y with one another, it means the same thing. Okay, so yes, a log function is the inverse of the exponential function. And I could also say that the exponential function is the inverse of the logarithmic function. Okay, so the word inverse means either x and y have been interchanged, which is the same as a reflection over the line y equals x. Okay, so is J a cubic function? Yes, that's a cubic function. That is a cubic function. So you're going to learn a lot more about those in calculus this year. Let's just have a look at G before you guys go. All right. So my question to you is G a function? Is G a function? Yes or no?
Yes.
Yes, G is a function. Okay. Is it a many-to-one function or is it a one-to-one function?
Many-to-one.
It is a many-to-one function, quite right. So in G, we would say that this is a many-to-one function. Now, all right, the domain and the range have been restricted. There are no arrows. Okay, can you see how the arrows at the ends over here? We do not have them in G, right? So now, how are we going to write the domain? How would we write the domain in this case? Good, guys. Many-to-one. Good, 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 good. Yes. All right. How would we write the domain? Lemochang, you're welcome to unmute and speak. Lemochang, how would we write the domain?
The domain of
G.
Is x element of a square bracket -2, 2.
Good. And then another square bracket. Okay. So can you see? Good. That's lovely, Lemochang. Can you see how that's different to these other parabolas that we have here? Okay, because they were showing us how they keep getting wider in C and D and E. It keeps getting wider and wider. Here it stops. It doesn't get past -2 and it doesn't get past 2. So that's really nice. Now we want to write the range. Okay, so Dimple, I want you to tell me what the range would be, please, for question G. What is the range? This is a difficult question. Go for it.
The range for
got for number G is going to be y is an element of block bracket 0 up to 2 block brackets.
Excellent,
No.
excellent, excellent, excellent. That's really nicely done. Well done. Very good. Okay, nice.
you.
Lovely. Okay, now our alternatives here, as far as our domain is concerned, our alternative way of writing it, that's interval notation. We can also write it like this. So in other words, x is greater than or equal to -2, but smaller than or equal to 2. That would be our alternative for the domain. Our alternative for the range would be y is greater than or equal to 0, but smaller than or equal to 2. So that's our alternative way of writing it there. Okay, let's just see what you guys are saying in the chat. Yes. Okay, but Sehufatso, do you understand why it can't just be y is smaller than or equal to 2? Because in terms of y, it doesn't get any smaller than 0. It stops at the x-axis. Okay. All right, Unarine, that's lovely. I hope I said your name correctly. Perfect, perfect, perfect. Okay, now, what about question I? Who's going to do question I for us? Any takers for question I? Correct.
Can I try?
Go for it, Nasipo. Lovely.
Why I, this is I, right? Yes.
I, correct, yes.
I is a one-to-one function.
Lovely. Yes. Keep going.
The domain would be x is an element square bracket
No square bracket.
or round bracket.
Uh-huh.
Negative. Is it negative infinity or is it 0?
No, it's negative infinity, okay? Because it keeps going wider and wider and wider. Okay, so
Right.
negative infinity is correct.
Negative infinity is to positive infinity.
Good, yes, lovely, well done. That's exactly correct. Okay, now do you want to tell me what the range is?
The range would be y is an element
Keep going. Maybe we lost you, Nozipo. Katie, do you want to do it?
Yes, ma'am.
Go for it.
Y is an element of round bracket 0 to positive infinity.
Beautiful. And then?
Round
bracket. Good, Katie. Lovely. Okay, very, very nice. Well done. Perfect. Okay, so it can't be an element of the real numbers, Katlejo, because y is only allowed to be positive. It's not allowed to be 0, because remember, it's an exponential function, which is what Cabello and Ria were saying. Okay, Cabello, it's an exponential function. Okay, so that means it's got a horizontal asymptote. In this case, the implication is that the x-axis is the horizontal asymptote. That's what they're trying to indicate in the diagram. Okay, so here, the other way that we would write the range is we would have to say y is greater than 0. Okay, not greater than or equal to. Okay, not like the parabola. Okay, with a parabola, we could say y is greater than or equal to, because 0 is one of our outputs. It is our minimum. Y is allowed to equal 0. Here, y is not allowed to equal 0. Okay, it cannot touch the x-axis. It cannot touch the line y equals 0. Okay, all right, let's just have a look. That's all your questions. Pinga, ma'am, there wouldn't be a square bracket at the 0. No. for exactly what I've just explained now. Okay, Pinga? Because it has an asymptote. Parabolas don't have asymptotes. Okay, so not a square bracket at the 0 in this case. Ola, so maybe we put the round bracket around the 0 and the infinity. For this one, yes. For this one, yes. Okay, Wasani, when we use a round bracket, that is when we either say that something is smaller than or something is greater than. So in other words, whatever value we are referring to, it is not included. When we use square brackets or block brackets, then we are saying smaller than or equal to, or greater than or equal to. So whatever values we are talking about, they are included. Okay, so that's the difference between a round bracket and a square bracket. Round brackets are when the value is not included. Square brackets are when the value is included. Okay. All right. Are there any? Yes, absolutely. So I'm just sorry, I'm saying absolutely, but let me just read your question. So ma'am, when restricting a function, are we actually removing one part of the function? Essentially, yes, Wasani. So in other words, what would happen, let's just get some space here. All right, just very quickly here at the end, okay? Let's draw a parabola. Okay. If I want to make, so this is a function, right? It's a parabola and it is a many-to-one function. If I now go and take this and I reflect it over the line y equals x, right? It's going to end up looking like that. Now it's not a function anymore. So what I need to do is I need to restrict the domain on the original function. So when I restrict the domain, either I look where x is positive, or I look where x is negative. So in other words, now when I have drawn this, okay, if I now reflect this over the line y equals x, right, it's going to look like, sorry, like this one. Okay, that would be, so I have to restrict the original domain, right? If I'm going to do this part over here, and I'm going to look where x is equal to negative, then that would be that part over there, right? So you have to restrict the domain of the original function, okay, in order to be able to do that. So either you look here where x is smaller than 0, or you look here where x is greater than 0. Okay. So yes, you're essentially removing one arm of the parabola in order to make the inverse a function as well. Okay, but Wasani, don't worry about this. We're going to talk about this in detail in one of our coming lessons. Okay,